So for this problem, to evaluate this integral using this trigonometric substitution, so first in the denominator, we need to create a perfect square trinomial. So just focus on the first term and the second term. So from the first term, we need to find the factors, and the factors must be the same. So for this 16x squared, so this is equal to 4x times 4x. So again, these two factors must be the same. Then since the middle term is negative, so all minus. And from the second term, we need to find the same two numbers, and the sum is 40. So since 40 is equal to 20 plus 20, so again, the same two numbers. So from this, we can find now the second term, because 20 divided by 4, so this is equal to 5. Then multiply these two numbers, so 5 times 5, this one is 25. So in the denominator, we need to add the positive 25 and the negative 25. So if this is the given, 4x squared minus 12x minus 7, and then again, find the factors of the first term, and the factors must be the same. So this one is 2x times 2x. Then since the second term is positive, so all plus. Then in the second term, the same two numbers. Then the sum is 12. So 6 plus 6. So we can find now the second term, because 6 divided by 2, this one is 3. And multiply these two numbers, 3 times 3, this is 9. So we need to add positive 9 and negative 9. So from this, we need to simplify this negative 25 and positive 16. So this becomes 16x squared minus 40x plus 25. And this negative 25 and positive 16, that's negative 9. Then to find the factors for this 16x squared plus 40x plus 25. So that is equal to 4x minus 5 times 4x minus 5, or this is equal to 4x minus 5 quantity to the power 2. So this becomes 4x minus 5 quantity to the power 2. And for this 9, so this is equal to negative or minus 3 to the power 2. So we have now the values for u squared minus a squared. Therefore, we let u equals a secant theta. Then we need to find the value for u and a. So u is equal to 4x minus 5. Then a is equal to positive 3. Then we need to substitute now the value for a and u from this equation. So we have u, and u is equal to 4x minus 5, then equals a. A is 3, then secant theta. Then to solve for x, we need to transpose this negative 5 to the other side. So this becomes positive 5. And to solve for x, divide both sides, or every terms, divide by 4. So x equals, this is 3 over 4, then secant theta, then plus the 5 over 4. Then we need to find out the derivative for x. So just bring down the constant. Then for the derivative of secant theta, this is equal to secant theta tangent theta. Then for the derivative of a constant, this one is 0. So we have 3 over 4 secant theta tangent theta. Then we need to add the d theta. Then we can apply now the trigonometric substitution from this equation. So first, for dx and dx is equal to 3 over 4 secant theta tangent theta d theta. Then for this 4x minus 5, and 4x minus 5 is equal to 3 secant theta. So this becomes 3 secant theta, then to the power 2, then minus 9. Then we need to put this constant outside and simplify. So this 3 to the power 2, this is 9. Then secant squared theta minus 9. Then we need to factor out this 9. So put this 9 outside. So therefore, putting this 9 outside, the remaining is secant squared theta. And for this 9, divide by 9. So this is 1. Then apply now the identity for this secant squared theta minus 1. And since secant squared theta minus 1 is equal to tangent squared theta, then we need to multiply this 4 times 9. So this one is 36. So we have 3 over 36. And cancel now this tangent theta. Cancel 1 tangent theta. So in the denominator, that's tangent theta. Then we need to reduce this 3 over 36. So divide by 3. So this is 1 over 12. And for this, secant over tangent. So secant over tangent, this is equal to cosecant. Then to find out the integral for this cosecant theta. So this is equal to negative ln. Then cosecant theta plus cotangent theta, then plus c. Or you can have this positive ln. Then we have the cosecant theta minus cotangent theta plus c. Then we need to simplify. So multiply this negative. So we have negative 12. Then ln cosecant theta plus cotangent theta plus c. Then from this, we need to find out the values for this cosecant theta and cotangent theta. So from this equation, from 4x minus 5 equals 3 secant theta. Then to solve for secant theta, so divide by 3. Divide by 3. So therefore, secant theta is equal to 4x minus 5 over 3. Then since secant is equal to hypotenuse over the adjacent, so in a right triangle, this is now theta, and this side is the opposite. This side is the adjacent, and this one is the hypotenuse. So the hypotenuse is equal to 4x minus 5, and the adjacent, that's positive 3. So to find out the opposite using these formulas, so again, we're looking for the opposite. So we have the square of the hypotenuse, then minus the square of the adjacent, or the unknown side is the square root of this given denominator. So that's 16x squared minus 40x plus 16. Then from this, we can find now the value for this cosecant and cotangent using these trigonometric identities. So again, we're looking for the cosecant, and cosecant is equal to the hypotenuse over the opposite. So we have the hypotenuse, we have 4x minus 5, and the opposite, so the square root of 16x squared minus 40x plus 16, then plus for the cotangent, so cotangent is equal to the adjacent, and the adjacent is positive 3, then over the opposite, so the opposite, that's square root of 16x squared minus 40 plus 16. Then since the same denominator, so we can combine. So this becomes 4x minus 5, then plus 3, and this negative 5 and positive 3. So this is equal to 4x minus 2. So this is now the integral using the trigonometric substitution.